This video is over section 2.4 and it's over linear functions. Mostly what we'll be doing is graphing functions, which a lot of this should be review from stuff that you've done before. So I'm just going to kind of run through it quickly, try to jog your memory. So a linear function is anything that can be written in the form of f of x equals ax plus b. Okay, now that's kind of how your book describes it. Probably in the past you learned it as y equals mx plus b, where m is the slope and b is the y-intercept. And so just to kind of start off with the first example, we're going to graph the function f of x equals negative 2x plus 6. All right, so to start with, the first thing that I would do when I graph it is I would graph the y-intercept. So the y-intercept in this case is 6. And so I'm just going to sketch out a graph here. And so keep in mind that this is where it crosses the y-axis, which is your vertical line. So I'll put a point at 0, 6. And then your slope is the number in front of x. And we want to think of this as rise over run. So in this case, it's not a fraction, but we always want to think of slope as a fraction. So it's going to be negative 2 over 1. So the way we get our second point from the line is we start at the y-intercept. I'm going to count down 2, because it's negative 2, down 2, and then over 1. And then we can just draw the line through those 2 points. Now the other thing you need to be able to do is state the domain and range. And for linear functions, with just there's an exception to this, but for the most part, every time the domain and range is going to be all real numbers. And so that's all you would need to do for a problem like number 1, being able to graph it accurately and then get the correct domain and range. Now, just taking a look at a couple of exceptions here. Just go over here to the side. So we had a problem like this, f of x equals 3. Okay. Now, as you're going through these, if you're confused by the f of x, of course you can always replace that with y. So that's the same thing as y equals 3. So in this situation, anytime as y equals something, this is a constant function where it's just going to be a horizontal line. And so that's the key thing, is that every time you can only have a y and there's no x, then you're always graphing a horizontal line. So in this case, because y is 3, I go to 3 on the y-axis and then just graph that line. Now the domain and range for horizontal line, in this case, that's a little bit different. The domain is still all real numbers, but the range, there's only one y value, and it's 3 all the way across. So the range is just 3. Okay, so that's the exception. Most of the linear functions that you graph, your domain is going to be all real numbers for both. The domain and range will be all real numbers for both. But if you have a horizontal line, you have to understand that the range is going to be just that number, that y equals. Okay, so the other exception is if we have a problem like x equals 7. Now this actually is not a linear function, but it is a straight line and you have to be able to graph it. So in this case, whenever you have just x equals, this is going to be a vertical line. And so sketching this one out, I'd go to where x equals 7, 2, 3, 4, 5, 6, 7, and then graph the line. In this case, your domain, there's only one x value, which is 7. So the domain is 7. And the range, which is all your y values, that's going to be all real numbers. All right, let's take a look at one more in this video. So let's go ahead and graph another line. Okay, so in this case, this is not in slope-intercept form. And so typically to graph, and of course there's different methods, and if you know another method, you're welcome to use it. But what I'll pretty consistently do is get this into slope-intercept form and then graph it from there. So that means I want to get y by itself. So we'll start by subtracting 4x from both sides. And then I'm dividing everything by negative 5. So we get y equals 4/5 x. And then there's no other number out here. Okay? So now that this is in slope-intercept form, the y-intercept, well, because there's no number up here, the y-intercept is 0. and the slope is 4 over 5. So when we graph this line, hit a point at the y-intercept, which is in this case is just 0, so I'm going to go through the origin. And then my slope is 4 over 5, so I'm going to positive. So I'm going to rise 4, 1, 2, 3, 4, and then run over 5, 1, 2, 3, 4, 5. And there's the graph.